Now we use of Newton-Leibniz formula. We use Newton-Leibniz formula in evaluating the limits. Okay. First we learn what is Newton-Leibniz formula. Let us a definite integral is Ix is of the form limit over phi x to psi x ft dt. Now if you want to evaluate its differentiation, what will be that? For this, first differentiating upper limit with respect to x, psi dash x, then put psi x in f in place of t, which will be f psi x minus, then lower limit, differentiation of lower limit, phi dash x, and substitute phi x in place of t in f phi x. This is the Newton-Leibniz formula. Okay. Now we learn how to use this in evaluating limit. Okay, take one example for this. Evaluate limit x tends to 0, x minus 0 to x cos of t square dt upon x cube minus 6x. Okay. Limit x tends to 0, x minus 0 to x cos of t square dt upon x cube minus 6x. Okay. Look at this. If we replace x by 0, then this will be 0, and then replace x 0, this will also be whole integral will be 0. Then 0 minus 0, 0. Here also 0, 0, then 0 upon 0 form. Okay. Now we 0 upon 0 form, we apply L'Hospital rule. Applying L'Hospital's rule. What the L'Hospital rule say? Differentiator, numerator and denominator. Then differentiating this. 1, differentiator of x is 1, minus differentiation of this d upon dx, integration of 0 to x cos of t square dt upon 3x square minus 6. We will evaluate differentiation of 0 to x cos t square dt separately. Okay. D upon dx 0 to x cos of t square dt. We have studied L'Hospital rule. L'Hospital rule says differentiation of an integral will be first differentiate upper limit with respect to x. Differentiation of x will be 1, and substitute x in it, cos of x square, minus further differentiation of lower limit, which is 0. Hence, by applying the Newton-Leibniz formula, this will be cos of x square. Okay. Now put this value. Limit x tends to 0, 1 minus we replace the value of d upon dx, 0 to x cos t square dt by cos x square upon 3x. 3 can be taken out, x square minus 2. Further we can say, look, when we apply limit x tends to 0, then this will be 0. Okay, limit x tends to 0, upper, which will be applying limit x tends to 0, this will be 1 minus 0 upon 3, 0 minus 2, which is 1 upon, sorry, this is 1, 0 upon minus 6. As we see, now I hope you understand how to evaluate the limit by applying the Newton-Leibniz formula. Thanks for watching.